Okay, hello everyone. So this is the second video of integrals of trigonometric functions. If you haven't seen the first video, then just go see it now. Today we're just continuing with the material that we built last time. So in the last video, what you saw was how to find the antiderivatives of 6 trigonometric functions over here, based on the derivatives of trig functions that we already knew, right? So we just differentiated a bunch of functions, and then based on their derivatives, we're able to find the original functions over here. Maybe you've already realized that this doesn't really allow us to find antiderivatives for the functions tangent, secant, cosecant, and cotangent, right? So even though it happened to give us the antiderivative, for example, for secant squared of x, we still don't know how to evaluate the antiderivative of just secant of x, or just cotangent of x, or just tangent of x, or just cosecant of x. So that's what we're going to be doing today, along with a couple of examples in which we're using these. So in order to start this, we're going to first find so we're going to start with an example, which will allow us to find the antiderivative of the tangent function. So we're going to evaluate the antiderivative of tangent of x. And the idea here is to evaluate this antiderivative based on what we already know, which means based on either of these antiderivatives that we know here. Now, of course, in neither of these do we have the antiderivative of just tangent of x, which means we're going to have to try something else. And in trigonometric functions, it's usually a good idea that if you don't know how to do anything else, you try to rewrite things in terms of functions that you do know how to deal with. So in this case, for us, that means that maybe a good first step is to write this as the integral of tangent of x, but rewrite tangent of x in terms of the functions that we do know. So that would mean we have sine of x over cosine of x, and then we're still evaluating the antiderivative of that with respect to x. All right, so this gives us a starting point, but now we actually have to come up with a way to integrate this. If that's what we want to do, that means we're going to start by doing probably something else, right? So like, again, this is not one of the antiderivatives that we know yet. Sine over cosine of x we don't have, which means we're going to have to do something else. Now, at this point, you have the cosine of x at the denominator, and we know, we're pretty comfortable with this, we know that the derivative of cosine of x is sine of x. So this should be a pretty good hint that maybe if I do a substitution and I choose u to be cosine of x, then I should normally be able to replace the sine of x dx and do my full substitution. I'll have a plan for everything in my integral. So that means du over here would be the derivative of cosine of x, which of course happens to be negative sine of x dx. And that means that if I want to replace just sine of x dx, I'm going to have to multiply everything, left-hand side and right-hand side, by minus 1. So then I'll have minus du is equal to sine of x dx. And that's great because it gives me a plan for everything, right? Now I can replace sine of x dx with just minus du, and I can replace the cosine of x at the denominator with just u. So by doing this, I'm going to have the integral of sine of x dx was replaced by minus du, and I can write that as minus 1 times du, and then the denominator I had cosine of x, which was equal to u, which means that now I'm integrating negative 1 over u times du, and that's actually a pretty easy integral to evaluate. This is just the antiderivative of negative 1 over u, which by now we are pretty comfortable saying is equal to minus ln of absolute value of u plus c. And then we just have to back substitute, replace u by its expression in terms of x, which is ln of cosine of x. Okay, so now we have the antiderivative of tangent of x with respect to x, which is equal to minus ln of cosine of x. All right, so this is the way that I'm going to be writing this in my class. But if you ever Google answers to anything else, you might see an alternative way of writing this integral, which could be, let me just write that in a different color. Sometimes you'll see this written as the integral of tangent of x with respect to x would be equal to ln of secant of x plus c. And if you see this, it's not because, I integrated this wrong, but just because ln of secant of x can be rewritten as minus ln of cosine of x by just using some of the properties of the logarithms. So you might remember from previous classes that if you look at minus ln of any given number a, that is equal to ln of absolute value of 1 over a, right? So if I apply this to the result that I got, which is minus ln of cosine of x, so minus ln of cosine of x, then that means that this is the same as ln of absolute value of 1 over cosine of x. And I know that this function over here is actually just secant of x, which would mean that this is the same as ln of secant of x plus c. Well, not plus c in this case because I'm not looking at that really. Minus ln of secant of x. There you go. All right, so all that that's saying is that this term over here, minus ln of cosine of x, can be replaced by ln of secant of x. They're equivalent statements. They're just written in a different way. All right, so this is the proof for how we find the integral of tangent of x with respect to x. Now, what I want you to do is to take a couple of minutes in order to do the same exact thing, but to find the integral for cotangent of x with respect to x. Okay, so write in terms of sine and cosine and evaluate the integral. Pause this, and when you're done, you can keep watching. Okay, so now that hopefully you've tried to evaluate these on your own, I'm going to give the actual rules, the missing rules that we have for this part. So that would be proposition, integrals of trig functions, and this is just part 2. So these are just the ones that we were missing, and so that means I'm going to start my counter at 7. I have 7, 8, 9, and 10. All right, so these are the integrals that I want. The first integral that I'm going to look at is the antiderivative of tangent of x, which is the one that we just evaluated a couple minutes ago. And that is minus ln of cosine of x plus c. And now if you try to do this on your own, you will have seen that the antiderivative of cotangent of x, normally by doing the same exact thing as before, you should have found that this would have been equal to ln of sine of x plus c. Okay, so very similar substitution then for these two integrals. The ones that are a little bit trickier are the antiderivative of secant of x with respect to x, and the antiderivative of cosecant of x with respect to x. So the antiderivative of secant of x with respect to x is just the logarithm of secant of x plus tangent of x plus my constant of integration, and the antiderivative of cosecant of x is minus ln of cosecant of x plus cotangent of x. again, plus my constant of integration. If you want to try to evaluate these on your own, which I'm not going to be doing in this video, but it uses one of the techniques that we've used a lot in calculus, what you'll have to do is to multiply by what we call, or I usually call, a smart one, which basically just means multiply the numerator and the denominator of the function that you're integrating over here by the same thing, right? So if you multiply and divide by the same thing, that means you're just multiplying by 1. And the smart one is going to be a little different for 9 and 10. So for the antiderivative of secant of x, you'll have to multiply top and bottom, or multiply and divide, by secant of x plus tangent of x. And once you do that, afterward, you'll just have to do a substitution. And for problem number 10, you'll have to multiply the numerator and the denominator, or multiply and divide, by cosecant of x plus cotangent of x, and then do a substitution as well. So because you're going to be doing a substitution that involves trigonometric functions, you're going to have to go back to your part, to the part over here where you have the derivatives of the trig functions in order to replace your du once it comes to that. Okay, so these are now properties 1 through 10 are all the antiderivatives of trig functions that you will need for this class. And in the next video, I'm just going to show a couple of examples of how to use those in order to evaluate specific integrals.